Sodium hydroxide. So number 7.
How many milliliters?
Oh. Thank you. It probably would help if I held this in my hand.
And it's the molarity of sodium hydroxide.
How many mils? Yeah, how many mils is sodium hydroxide? Thank you. 0.1 molar sodium hydroxide are needed to prepare a Okay. Here we go, and this is another one of those where we're gonna, we did this derivation
Yeah.
at the end of the lecture last night. And so we're gonna try and sort of, rather than doing that whole derivation, we're gonna sort of do it piecemeal. By just taking into account the definitions. This is a buffer. What famous equation are we going to use?
Henderson-Hasselbalch.
Henderson-Hasselbalch. And we've already talked about how to derive Henderson-Hasselbalch. And so, what was Henderson-Hasselbalch? In case you forgot, you can look at your scratch paper because you derived it for an earlier problem. But pH, somebody answer that, would you?
It's 4 o'clock.
That's cheesy. I mean, you know, the bells used to sound good. That sounds cheesy.
Yeah.
The old recording was better than the new
We
recording.
should have a tower somewhere with a bell. That would be really
When
cool.
they were building all these new
And we
buildings.
could have a hunchback that came. So pH is equal, what does Henderson-Hasselbalch have?
pKa minus log HA over AA.
And this is going to be, in this case, HA is HF. Okay, and this is not A. I've got A's on my brain. Okay, the hydrofluoric acid over the fluoride ion concentration. And now I'm just going to start out from the start by what is the pH I want?
4.
4 equals, and what was pKa?
3.167.
Minus the log of HF over F. And I'm going to get rid of this pen. Okay? Now, the reason I did it this way is because I can now just take care of, this is just a number. I might as well do it right now. 4 minus 3.167, I gotta go 4, this is my scratch paper, 3.167, that's 3, and that's an 8, and so, yeah, 0.883, so 0.833 is equal to the minus log of HF over F. And now, on my scratch paper, or no, hell, we don't need my scratch paper. Let's go ahead and 10 to the minus, I can take the minus sign over here, 0.833 is equal to and that I'm going to now write out an expression for, which involves the initial volume. And I'm going to use liters. Now I had what was my initial volume of, this is
40
basically the same thing we did. Same thing we did before. I'm going to take, what was the molarity? The molarity is going to drop out. 0.1 molar. 0.1 molar times what was the initial volume of the material.
0.040 liters.
What?
40 milliliters. 40 milliliters.
So I have 0.04 liters minus, and now I've added some of the base, minus X liters, so I'll just call that liters, over 0.04 liters plus X liters. That's the top half, and the bottom half is 0.1 molar times X liters over 0.04 liters plus X liters. And now I've got my awkward, ungainly looking material here, which simplifies because this all drops out, and I have something that's equal to 0.04 liters minus X liters over X liters is equal to 10 to the minus 0.833. Okay. Now, so XL times 10 to the minus 0.833 is equal to 0.04 L minus X liters. And now I can simplify this one tremendously by adding XL to both sides. So XL times 1 plus 10 to the minus 0.833 is equal to 0.04 liters. And X liters is equal to 0.04 liters over 1 plus 10 to the minus 0.833. And now we're going to have to get close with that one. What is 7? Well, no, let's, no, 833.
That's 8.
It's to the minus 833. How do I end up with a negative? Okay.
You had a positive, but when you did the negative log, you switched it to a negative.
Yeah.
You divide by negative and then did the log.
Yeah, I did the log on that side. I should have done it. Yeah. I should have kept it that way. I should have kept it minus on. I should have kept the minus on that end. Oh well. Yeah, would that have made life easier? Okay, I can handle this, but it's going to be very interesting. That is equal to 10 to the minus 1. Oh, 10 10 to the minus 0.833 is equal to 10 to the minus 1 times, and I do the complement, 1.000833. That's 7, that's 6, and this is 1, 6, 7, 10 to the, okay. 10 to the minus 1 times 10 to the 0.167. You have to have a positive number in the mantissa times some sort of a negative thing, so it's going to be equal to, 0.167. That's awfully close to 1 point, or 0.1.
Yeah, it's like 10.301, like, divided by 2.
Yeah, it's around, so it's got awfully close to, it's not 2, it's less than 2, it's between 1 and 2, so it's around 1 point.
But it's closer to 1.
It's close to 1, but it's we could get there. It's going to take a little bit of work. We're just going to give it an approximation. It's around 1.5, let's say, just for laughs. I mean, it's between 1 and 2. So it's around 1.5 times 10 to the minus 1. So that is equal to 0.04 liters over 1. This is a round equal to 1 plus, this is going to be a round equal to 1.5 times 10 to the minus 1, which is 0.15. Okay, and so that's going to be 1.15, so I divide equals 0.04 divided by 1.15. Okay, now I just got to do that. Tedious mathematics, but this is all scratch paper stuff. 0.04 divided by 1.15. Move this over 2, this over 2. And 115 goes into 1.15. Okay, this one's going to go, this one's going to go way over here. It's going to be 0, 0. 115 goes into 400 3 times. And that would be 345. That's 5. That is a 5. And so 550, so it's going to be around 3, 4, that's going to be 4. Maybe 5, no, 345, 460, yeah, it's going to be 4.34. So this is equal to 0.034 liters equals 3.4 milliliters. Okay.
There we go.
Yeah. And for whatever it's worth, this is pretty straightforward. This last part was
Not
just
as straight
because.
as it might seem.
But
Not as straight as you think.
yeah, the last part got a little bit messy. Again, I'm going to have one on the actual test that's going to work nicely. We could derive.
In the meantime.
Okay. In the meantime, we could go do the expression we derived, which I was trying to avoid. You want me to bring up that one?
I wouldn't think that would be necessary. I can't quite comprehend this.
Okay. Well, we can do that one.
No, it's fine. We're done.
Okay. So 3.4 milliliters. Okay. That will be a wrap. And let me see.